Good morning and welcome to the Copper and Brimstone Lab. This lab is composed of basically two parts. The first part is a get to know your Bunsen burner lab, and it talks about how basically you want to, once you get your flame lit, you want to mess around with the Bunsen burner. This bottom part here controls the size of the flame, the overall amount of gas entering. This controls the gas to oxygen mixture, controls the type of flame. Alright, so the first thing it says is a procedure one at your station you should have a test tube, two beakers, which I have down below here, and if you don't have these, find them. Okay, and then I also have a stir stick here as well. Either way, it says number 2, it says mass solid sample 4.5 grams and 1 gram of copper and sulfur respectively. I did that. Use your individual beakers to hold the samples. Number 3 says observe the copper and sulfur and note some of its physical properties in the data tables. You should create your data table, and you'll notice that sulfur here is yellow. It's powdery. It moves around pretty good. It's got most of the properties of non-metals. Alright. Smell-wise, sulfur kind of has a little bit of that match burning smell, but have to wait to actually burn it to get that good smell. And then here we have copper. Copper is, it's copper, so we have, it's got copper color. Here we go. Somewhat malleable. This is I'm using chunks at this point, but you could easily use dust of some sort like that. Okay. Just copper. So those are the physical properties of the stuff that we are using. We're going to take these guys and we're going to mix them together. So let's see what it says for the next instruction. It says observe. We did that. Number 4, pour the sulfur and copper into the test tube. Mix with a stirring rod for 10 seconds as the contents are mixed. Is this reaction physical or chemical? Okay, so I'll just dump this together. I could even, for this purpose, I'll mix them in this beaker here, and just for viewing reasons. You can see that at this point they have mixed together. It says to wait a little bit, but as time goes by, you'll see this is nothing more than what we would refer to as a heterogeneous mixture. More of a physical combination than would be considered a chemical reaction. No new substance has been formed. Number 5 says cover the open end of a test tube and with aluminum foil squares and secure the aluminum foil square rubber band. So we'll take our test tube here and we'll pour this stuff in here. Get it in there and just dump it in here. Okay. Take your aluminum foil and cover it. Now, I'm not exactly sure why we cover this, but other classes, some classes don't, I've seen. Basic attempts to keep some of our stuff in the test tube, some of the gases. Occasionally the pressure builds up and pops this little aluminum foil off. But that's now fully, see it's dirty already. In the previous experiment, that's fine. Sometimes we have to break these to get the stuff out anyway, so we like to reuse these as much as we can. They don't clean up real well, so it's good to go. Number 6 says put the test tube into the test tube clamp and secure the test tube clamp firmly to the ring stand. Tilt the test tube and aim the mouth of the test tube away from people and or common pathways. Clamp or any rubber part should be free of the flames. So one of the important things about just being in lab is being able to look at all these little screws and turning things to be able to get this thing to work. We don't want to burn this thing, so I'll clamp this near close to the top of the test tube. Swing the end of the butt end of the test tube out, so that when the flame comes up, it's hard to tell from the angle of the camera, but I don't want the flame to touch the finger, so I'm going to get it a little more towards you. Alright, and here we go. Alright, so next thing is just to turn on the Bunsen burner. For that purpose here, got matches, got to reach over it, light it up. I have to turn the gas on. At this point you should be listening for it. I can hear it. Light the match right at the tip thing here, tip of the Bunsen burner, and there it goes. Shouldn't take real long. It gets pretty hot. Make sure you're at the cone. That's how well you can see this. Let's try this once. I'm not going to be able to get that camera that close. Alright, so it doesn't take long. Once you see, you'll see gases forming inside here. The sulfur immediately turns black. Stuff starts mixing up, and once you stop seeing any changes occur, we can simply then stop heating the test tube. And at this point, to me, it looks like nothing else is occurring. I'm going to turn this off. Okay. So number 7 says heat the test tube using Bunsen burner. Okay. Number 8 says notice changes that are occurring and record them in the table in your section. Number 9 says reaction is done when no further changes are occurring. After reaction has taken place, allow test tube to cool. Number 11 says gently tap the test tube upside down onto a piece of paper towel which is on top of your notebook. If the substance is stuck, roll the test tube in a piece of paper and crack open with a blunt object. See picture. So basically we would like to just see if a chemical reaction has occurred. Does our new substance have new properties? So we would take this thing on the top is not all that hot. When students do this lab, they tend to burn the living crap out of the thing. So it gets really hot. The bottom is hot. Notice how nicely it even kind of cleaned out. I'm going to pull this thing out of here and give the camera a little better view of it. So in this case, you'll see that yeah, it's an interesting little substance there. It cleaned the bottom out nicely. I bet you if I wanted to clean these test tubes, I could probably use heat to clean these test tubes out. But we have a new substance in there that is got looks like some new properties. It doesn't at this point has not cooled sufficiently for me to get it out of here yet. But yeah, it's definitely going to take a few moments. Alright, so welcome back. This thing has now sufficiently cooled. Looks to me like what I would want to do is try to get this thing out of here. And you can do that by tapping it on something. I think the instructions mentioned to use a piece of paper towel on top of your lab book. That is much I could do here and be kind of hard to see in the video, but if this thing doesn't come out within a few quick clicks, then your taps and you're going to want to pull it out. Some of the smells now, sulfur, when sulfur oxidizes, it gets kind of smelly. So that being said, if it won't come out with, then break it. So take some paper towel, and you can see, I'll put it back a little farther here. You wrap it in paper towel, and you don't want to, you just won't want the glass to be retained inside of the paper. Just take it and give it a little crack like that. You don't want to break your substance, but then unravel it, and you will see this thing easily can just be picked up, and this thing here still looks a little bit kind of hard to see. The glass didn't separate from it, which is fine. You can at this point touch it and look at some of its new chemical and physical properties. A lot of times it ends up coming out of there and you can see it a lot better, but either way, that's the new substance. And that new substance, its actual name is copper sulfide. Alright.